Today we're going to look at solving quadratics using the quadratic formula. The quadratic formula is one of several ways that you learned in Algebra 1 how to solve a quadratic equation. If you have a quadratic equation, you can graph the related function and visually look to find those solutions, zeros, roots, x-intercepts. You could graph it. You can use square roots. You can factor it. You can use a process called completing the square, and you can use quadratic formula. You used all of those methods in Algebra 1. The quadratic formula is the best because it will find those solutions, zeros, roots, x-intercepts for any quadratic function. So remember those quadratic functions, we're talking about y equals x squared, making those cute parabolas and looking for those x-intercepts are our solutions. Now, why did I say any? And why are we going to only use the quadratic formula? Because in Algebra 2, you're introduced to those imaginary units. And so in Algebra 2, if we're solving a quadratic again from Algebra 1, the reason it comes back in Algebra 2, you guessed it, the answers are going to have imaginaries in them. And the only way to get an imaginary solution answer out of a quadratic is using the quadratic formula. Quadratic formula, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. It is a mouthful, but you really need to memorize it because it is not on our EOC reference sheet. In order to use the quadratic formula, your function needs to be in standard form, ax squared, then bx, and then your constant c in that order so you can pull out your a, b, and c. Look at your steps below. I said go ahead and start by setting your equation equal to 0 if it's not already. Identify those a, b, and c values. If you are missing one of those terms, use a 0 as a placeholder, and then we're going to plug those into the formula and solve. No decimals. We're leaving it in simplified radical form. Let's start with number 1, x squared plus 29 equals 4x. We need it equal to 0 and those terms to be in standard form. So let's subtract the 4x to the other side and write it as x squared minus 4x plus 29 equals 0. That means my a value is going to be 1, my b is a negative 4, and c is 29 for my quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Two things about the formula that sometimes students mess up. There is a lot of stuff under the radical. B squared minus 4ac is all in the radical, and then it's all divided by 2a. Sometimes I have students that just divide like the end by 2a, so make sure everything is being divided. Let's plug it in. We start with negative b. Our b value was negative, and this happens a lot, so watch out for it. We're going to have a negative 4 plus or minus the square root of b squared. So we have negative 4 squared. Notice how I wrote it in parentheses, because every time right there when you have that b squared in the radical, no matter what the value of b was, when you square it, it should be positive. That piece should never be negative after you square. Minus 4 times a is 1 for us, and c is 29. All of that's under the radical, and then all divided by 2 times a, which is 2 times 1 for us on this problem. Now, this is a lot. That is a lot to try to throw into a calculator, lots of space, lots of possibilities for calculator error, user error. Simplify by hand is definitely my recommendation. So let's go to the very beginning. Negative 4 makes a positive 4 plus or minus the square root of, what did I say? That negative 4 squared right there should come out as a positive 16. The next part, I multiply all three of these together in my calculator, negative 4 times 1 times 29. And that's going to give us a negative 116. All divided by 2 times 1 is 2. Look how much we just cleaned that up by hand. It looks so much better. Let's keep going. I'm going to finish it by hand. 4 plus or minus the square root of 16 minus 116. Negative 100 divided by 2. You see now what's going to happen now that we're in Algebra 2 and we know about imaginaries while we're solving quadratics? Imaginary solutions. So let me show you 4 plus or minus. I'm going to split it up into a negative 1 and the positive 100. That square root of a negative 1, that's our I, and the square root of 100 is 10. So our final answer looks like 4 plus or minus 10I divided by 2. Hold up 1 second. If you can simplify these three numbers, you should. If you can, you must. So our final answer, divide each of those terms by 2, will give us 2 plus or minus 5I. There's your final answer. Now, sometimes students ask me about that plus or minus. It's representing two different answers. We have two answers here. 2 plus 5I is one solution. 2 minus 5I is the other solution. So on Delta Math, there is a plus or minus button that you can use to write it all as one. Or if you want to write it separately, you can create those two solution boxes and write them separately, once with the plus sign, once with the minus sign. That is up to you. Let's look at number 2. We have 2x squared plus 144 equals negative 32x. Same thing, we got to set it equal to 0, get our terms all in the right order so we can correctly pull our a, b, and c. So let's add 32x to the other side. Putting it in order, a 2x squared plus 32x plus 144 equals 0. That means my a value is 2, my b is 32, and c is 144. Quadratic formula, negative b plus or minus the square root, b squared minus 4ac, all over 2a. Plugging it in, we have a negative 32 plus or minus the square root of 32 squared minus 4 times a, which is 2, and c is 144. We're going to have some big numbers here. All divided by 2 times 2. A lot of times our a value is a 1, so just be mindful that in this scenario, it's a 2. Don't get in the habit of always having a 2 times 1 in your denominator. Stay on top of your toes. Let's see. Simplify. I've got negative 32 plus or minus the square root of 32 squared is 1024. Minus, I multiply all of these together on my calculator. Negative 4 times 2 times 144 will give you a negative 1,152. Squeeze that in there. And divided by 2a, or 2 times 2, 4. Simplify some more by hand. We've got negative 32 plus or minus the square root of that 1,024 minus 1,152 is a negative 128. Divided by 4. Now, I see that negative. I know I'm going to have an imaginary, but 128. Let's break it up. So let's do the negative 1. And then what can we do about positive 128? So I'm reaching for my calculator. 128 divided by 4, 32. I think we can do better. 128 divided by 16 is still 8. And 8 still has a 4 in it, so I can definitely go bigger. I'm trying to find my biggest perfect square. 64? Yes, 2. So let's do 64 and 2, 64 being our largest perfect square factor of 128. And that would bring me to negative 32 plus or minus, I had my imaginary I. The square root of 64 is 8, and we'll leave the radical 2. So I have 8I radical 2 over 4. You're in the clear. Just if you can, you must simplify these three numbers, not the radical. Don't touch the square root of 2 part. Think of that as a variable. We don't change it. But the negative 32, the 8, and the 4, if those can be simplified, you do. All of those are divisible by 4, so we'll end up with a negative 8 plus or minus 2I radical 2. Final answer, there is two solutions written there, negative 8 plus 2I radical 2 and negative 8 minus 2I radical 2. Two places, two imaginary solutions for this quadratic. And number 3, our last one for these notes, 4x squared plus 85 equals 36x. Put it in standard form equal to 0. Subtract this 36x to the other side and put it in order. 4x squared minus 36x plus 85 equals 0. That means my a is going to be 4. My B is a negative 36 and C is 85. We're going to plug it into the quadratic formula, negative B plus or minus the square root of B squared minus 4AC all over 2A. A negative B, we have negative, our B value was negative. So a negative 36, watch out there, plus or minus the square root of negative 36 gets squared. That's going to be positive after I square it. Minus 4 times 85, all under the radical, divided by 2 times 4. So let's clean it up by hand. Those two negatives on 36, positive 36, plus or minus the square root of a negative 36 squared using parentheses should give you a positive number. It'll give us 1,296. Then I take my calculator and multiply negative 4 times 85, and that'll give you a negative 1,360. Divided by 2 times 4 gives us 8. Let's see. Let's simplify under the radical. We've got 36 plus or minus the square root of 1,296 minus the 1,360 gives us a negative 64 divided by 8. I'm liking the way this looks. 36 plus or minus that negative 64. Let's break it up into that negative 1 and a positive 64, and I'm loving it because 64 is a perfect square. We are getting an imaginary. The square root of 64 is 8. So we have 36 plus or minus 8i divided by 8. If you can, you must simplify these three numbers. Now, 36 is not divisible by 8, but it is divisible by 4. So we'll just divide each of these by 4, reducing it down to 9 plus or minus 2i divided by 2. Final answer for this quadratic equation number 3. So hopefully that was a good review of quadratic formula. Hopefully you recall it a little bit from Algebra 1. I know it's been a while. There are several ways to solve a quadratic, but because we're in Algebra 2, the only reason they're going to ask you to solve a quadratic in Algebra 2 is because it has imaginary solutions, and you're working with those negatives in your radicals and you're simplifying to get those imaginary solutions. So we will always use the quadratic formula, but the quadratic formula is not on our EOC reference sheet. So whatever you can do to memorize it, do that. I'm going to link my favorite YouTube video song that helps me memorize the quadratic formula. Watch that. I think you're going to enjoy it. And practice these. Go slow, simplify by hand, throwing it in the calculator, kind of a recipe for disaster. So let me know if you have any questions, guys, and I'll see you in class.